Hello, I'm Ondrej Mirtes, and thank you very much for coming to my talk. And the good news is that even if you don't like my talk, or if you don't learn anything new, you can still grab a sticker at the end. Yeah. And this is a huge, beautiful screen. I am so tempted to play some video games, like sitting in the back, but I was not allowed to do that. So we're just gonna need to stick with my presentation here. Okay, so who uses PHPStan? Yeah, almost everyone. That's really, really great news. So I really don't need to spend a lot of time introducing it. It's basically a stand-in for a missing compiler in PHP. So compiled languages like Java or C# are not going to let you run your application if you have some kind of obvious mistake like accessing to an undefined variable or call to an undefined method. But PHP is interpreted, so it's going to happily run your application, but it's going to crash when that error in some kind of nested condition in some that's executed only in some special circumstances is going to run. So PHP developers would have to spend a lot of time uncovering, looking for these mistakes by doing manual testing or writing a lot of unit tests, a lot of automated tests. But I realized that something like a compiler could also be written for PHP that would look for these mistakes throughout your whole code base automatically. So that's why I realized that something like PHPStan could be made possible. I had to invert the colors on my monitor so that you are not blinded by my bright slides. So errors that were supposed to be red are no longer red, they are blue, but otherwise, hopefully it's going to work out okay. And we need to talk a little bit about rule levels. So when I first started working on PHPStan, I implemented a single check and single rule, and I tried it out on a code base at the company where I worked at. And I fixed all of the mistakes the check found, and I merged the fixes, and then I continued working on PHPStan. So it was like a nice gradual introduction of the tool into the workflow, into the code base, and it allowed me to not have to fix all of the mistakes at once, but do it one by one. But right now, if you install PHPStan, and if it ran all the checks that it's possible, that it's able to, that it contains, that it's possible, that it's, if it could run all the checks, if it would look for all the errors that it's capable to do, it would print thousands of errors or even tens of thousands of errors on your code base. But that would quickly discourage you. You would uninstall it and you would never run it again, right? So that's why there are rule levels. Levels start at level 0, and level 0 only offers the most basic checks and looks for errors that really shouldn't be in your code base. But as you go up, the errors are starting to be a little bit more theoretical. They might not represent real bugs that you have in your code base, but it might be something that you might look into to get to a real get to the place where you feel the real type safety in your code. You really don't need to check out or remember what gets done on each level, but what you probably want to know is that on level 5, all basic bugs are checked. Everything like types assigned to properties, types of arguments passed to functions, everything like that is checked on level 5. But we still have something like 6, 7, 8, 9. We still have 4 more levels to go. So what happens on those levels? On level 6 checks for missing time hints, because without types, PHPStan is not able to do its job, because it would give you a false sense of security. Without types and without this level 6 that checks for missing type hints, you would be able to achieve the highest level, and you would get 0 errors, but it would give you just a false sense of security, because PHPStan wouldn't be able to check for any errors if you wouldn't give it any types. So that's why we kind of jammed the level 6 in between the simpler levels and the more advanced levels, so that you are forced to add all the missing type hints in your code base. And that also includes like array contents. So PHPStan is not satisfied if you type an array and you're not going to say what's in the array using a PHP doc. So you also need to add this kind of information. Level 7 is about partially wrong unions. So what does it mean? Let's say that we have a union type. We have a variable that contains either the foo type or the bar type. And we call a method on this type that's only on one of the types, one of the interfaces from the union. So up until level 6, no error is reported because it's possible that the code might be okay. If we are so lucky and we only ever pass the bar type into this function, despite the type hint, it's possible that our code is never going to crash in production. But it's risky, right? When someone passes foo into this function, it's going to crash. So this is reported on level 7. And it's not reported sooner, because what usually happens is that this information, what type is actually passed in the real application during runtime, might only be encoded in our developers' heads. So what sometimes happens is that we have a union, but we know that only this specific type is passed in this situation. So for example, if you are working with, if you are developing some kind of e-commerce website, e-commerce application, and you know that this piece of code only works with products on sale, you know in your head when you are implementing, when you are developing this application, is that only some types are possible in this situation, in this piece of code. But this kind of information is not always encoded in the types, so it's not machine readable. This information is only in your head. So that's why this is reported on level 7, and you might encounter situations like this. Level 8 is very similar, but it's about nullables. So if you have type bar or null, and you try to do something with this that really doesn't make sense on the null value, this is going to be reported on level 8. Okay, is anyone here who uses level 9? Wow, you're really brave. Well, of course, PHPStan analyzes PHPStan itself and looks for errors in PHPStan, but not even PHPStan uses level 9. PHPStan uses level 8 for its development. So level 9 is about limiting what you can do with the mixed type. Our PHP code bases are full of mixed. If you often work with API requests, if you often like decoding JSONs, if you are often reading files from disks and unserializing them, you are more than often using mixed type. And it's dangerous to do anything with mixed because it might be any type. So in this case, who wrote this piece of code is relying on the fact that the type that we are accepting is an object, and we are calling a method on that object. But it can be any type, right? It can be an integer passed into this function. But because our applications are full of mixed, this is reported on level 9 because it might be really hard to fix a lot of code that uses mixed. So this is really brutal. If you are not on level 9 and you increase your level to 9, PHPStan is going to report a lot of errors in your application. It's really brutal, and you don't have to feel like you need to achieve level 9. It's totally fine if you stay on level 8. It's better to have better experience with PHPStan, to not get frustrated. But of course, if you want to really want some challenge and you want to achieve level 9, you can try to do it. And what I strive for in my talks is that when you go back to work on Monday, you should be able to apply at least something from what I want to say here today. So who uses the baseline? Yeah, a lot of people. So the idea is that when you first start using PHPStan or you increase the level, you want to say that The errors in your code that you have them right now, they are okay because we know that our application does not crash in production. It more or less works. And you can say that the current 100 errors that you have in your code are the baseline. They are not going to be reported. There's going to be a file that generated file with all of these errors ignored. But once you or your colleagues submit another pull request and they add some code or they change some code, these new errors introduced in this new code are going to be reported on top of the baseline. Yeah, and you can use this feature pretty creatively, so you can use it to basically skip a level. So if level 6 tells you that you have a lot of missing type hints, but you're interested what level 7 has to say, you can set level 6, you can generate the baseline, and then you can increase the level. Basically, you will only get errors from level 7. And you can also use it if you want to introduce some new extensions, some new rules, but you don't have the time to fix all of the current errors in your code, but you are interested in new errors that are going to be introduced from that point on, you can use the baseline like that. All right, so the title of the talk promises maximum strictness, so I need to deliver on that. And who uses this package, PHPStan strict rules? Not a lot of people, so maybe I will encourage more people to use it with my points that I want to make. So PHPStan itself, out of the box, tries not to be too opinionated. So it tries to point out real bugs that you have in your application. But I also wanted to make some more opinionated rules, how I think that your code should look like. And this is what strict rules are about. So this is not going to be a complete list of what this package does, but only the most interesting rules that you should be interested in. So one thing that it's going to report to you is that you should have only booleans in conditions. So it's going to report this as an error because we are passing string or null to an if statement, to an if condition, and it's not obvious what was the developer's intention when they wrote it. Did they want to eliminate only null? Did they also want to eliminate only empty strings? We really cannot be sure what someone meant when they wrote this piece of code. But this, in reality, this does not eliminate non-empty strings. This eliminates false strings. Only truthy strings are going to be passed into this inside. This condition is going to be executed only if $s is a truthy string. So what is a truthy string in PHP? Yeah, sure. Some normal text is going to be cast to true. Number 1 is going to be cast to true. A string that contains number 0 is going to be false. But a string with 2 zeros is going to be true again. So if you are using this piece of code to, for example, eliminate some kind of invalid person's name or something like this is a really weird behavior to do that, right? So only booleans in conditions means that we need to write a really explicit condition to express what we wanted to do with this variable, what we really wanted to express with our code, what we wanted to eliminate. All right, another one, a similar one, is that we want to disallow the empty construct. And empty construct roughly evaluates to not being set or being false, but being false again with true equal signs, which is similar pitfall as casting to bool. Because comparing values with two equal signs in PHP is a completely random mess. Like, you really cannot remember this how this comparison table behaves, and you really shouldn't. What you should do instead is to use 3 equal signs, because that behaves really expectedly, in an expected way. So the only true comparisons with 3 equal signs are going to be on the diagonal between the same types, which will take less of your brain cycles when you are trying to read read the code and understand what it's trying to do. So PHPStan strict rules disallow empty, and it wants explicit comparisons, and it also requires strict comparisons with 3 equal signs or exclamation mark 2 equal signs. Okay, another similar one is that for functions like inArray or array search, you need to pass third parameter with value true, because that's also going to switch the logic to strict comparisons using 3 equal signs. Another one is that we don't want to use variables introduced inside our for each loops or for loops or a while loop outside of this loop. So by default, PHPStan does not complain about this because that would be opinionated, right? But if we can afford to be opinionated in the PHPStan strict rules, we can report this. And PHP allows this to work, right? If we are sure that the for each iterates at least once, then the last item of the array is going to be available in the variable below the for each, right? So by default, PHPStan does not complain about this, but if you install strict rules, even if the variable exists, PHPStan strict rules are going to complain that you really shouldn't be doing this, because it might have been the developer's intention to access the last item of the array, but at the same time, it might have been a mistake and they wanted to access a different variable, right? We cannot be really sure. It disallows dynamic code, so you can use $2 in a sequence, you can even use more dollars in a sequence, but that would get pretty meta, right? To access variables and to call methods and access properties in a dynamic way. So this is going to access a variable by the name that's in the $s variable, right? But with the dynamic code like this, the static analysis cannot do any useful job, right? Because we don't know what kind of variable we are accessing, if the variable exists, what type the variable is. If we are calling a method, we cannot be sure that the method is going to exist, and we don't know if the call is safe because the method that we are calling, might have some required arguments, right? So it's really a bad idea to use dynamic code like this. So it's much better to do some kind of dynamic dispatch, to write a match expression, to write a switch statement, and to have less dynamic code than this, to always be sure what kind of method, what method you are calling. Who knows what is object encapsulation? Probably all of you know what it is, but you just don't know what you just don't know this concept by this name. So the idea is that you shouldn't be able to break the object state by calling its methods, right? So we usually achieve this by having private properties and public methods. That's what they teach us at school, right? So by calling its methods, you should be able to break the state. So before the methods do what you want them to do, they should check that it's even possible to do the thing that you want to do. And when I'm implementing a class, I usually want to rely on the fact that the constructor is going to be called, right? Because I want to set some properties, I want to set some initial state. And if someone is extending my class, I also want to rely on the fact that the constructor is going to be called, right? So that's why PHP strict rules are going to tell you when you have forgotten to call the constructor of the parent class. And there are also some extra options in PHPStan that aren't part of any level. They are not part even of the strict rules package. You just need to know about them, or you need to listen to me right now, or you can check them. You can check them on the website in the documentation. So one of them is check uninitialized properties. And the idea is that when you have a property with a native type, PHP initially sets it to an uninitialized state, which means that it's unsafe to access this property. And if you don't assign it in the constructor, you have an object with an uninitialized property, which means that it's unsafe, it's dangerous to call the getter, right? And if you set this option to true, PHPStan is going to complain that you haven't set this property in the constructor. It's only part of this option. It's not enabled by default because sometimes people think they know what they are doing and they just create an empty object and they offer setters and they rely on the fact that the setter is going to be called before someone calls the getter, which can be really unsafe, but sometimes some frameworks, some libraries work this way, right? And I don't want to report false positives by default. So set check uninitialized properties to true, and you are going to be forced to set everything in your constructor. And obviously, I like this setting, but I cannot enable it for everyone. But what I sometimes do is that I attach stricter checks to new PHP features. So before PHP 8.1 was released, what I did in PHPStan is that when you have a read-only property, it's going to be reported even if check uninitialized properties is set to false. Because when you are creating a read-only property, I'm kind of assuming that you want to write an immutable object, and I can afford to do these stricter checks because I'm not breaking anyone's code, right? Before 8.1 was released, no one has written a read-only property because it wasn't possible in earlier PHP versions. So PHP does not require them to be assigned in the constructor, but I decided that I want to try this out, and I am reporting this even if you don't set any strict option to true. And of course that there are people that disagree with me on this, but they can just ignore this error if they know what they are doing. Or they can remove the read-only modifier, and the error is also not going to be reported. All right, so some people raised their hand when I asked they use level 9. Who uses this option? Check implicit mixed. Okay, only one person. So everyone who is already on level 9, I would encourage you to use check implicit mixed because it will simply lead to even more mixed errors. And the idea is that level 9 is about checking explicit mixed. Mixed, that it's your code, that's in your code. But implicit mixed is about variables with parameters and variables with no type. So this is the difference. If we type mixed, our parameter with mixed, this is going to be reported on level 9. But if you somehow manage to skip level 6, or if you ignore errors from level 6, or maybe if you call a library that doesn't have any type hints, you have a variable that has an implicit mixed type. It's unknown type because the mixed keyword wasn't anywhere in the code, so it's implicit mixed. And if you turn on check implicit mixed, the second example is also going to report an error. All right, the next topic is a little bit bigger one. So it's about pure and impure functions. Consider this piece of code. The person who wrote it probably relies on the fact that the getName method is always going to return the same value. And I am not holding it against them. It probably is going to return the same value, right? So inside the if statement, PHPStan is not going to complain that you are doing something with a possibly nullable value. And this is the default behavior because it's reasonable. People just expect this to work, right? So this kind of logic is beneficial in this example, but there are other examples where this is less beneficial. So PHPStan by default considers functions that return a value to be probably pure. And pure function means that it's going to behave the same way as long as it's given the same input, and input meaning the same argument values and also being called on an object with the same state. So in this case, it's beneficial, but when you are writing unit tests, it's going to be less beneficial because it's going to lead to this error. So we are asserting that getName is returning null, then we are calling setName, and then we are asserting that it's no longer null. But on the first line, PHPStan remembered that the getter is returning null. So the second assert is going to report that we are calling to method assert not null with something that is always null. So it can never be true. It's always going to evaluate to false. So in some cases, this logic is beneficial. In some cases, it's less beneficial. These are the default heuristics. So functions and methods that return a value are considered pure by default, and functions and methods that return void are considered impure because if you are not supposed to read a return value from a function, then the only thing that makes sense is that the function does something to the state of the object or to the global state, right? It has to do something. It has to print something. It has to save something to the database. It needs to change something in order to be useful if we are not supposed to read the value. And constructors are considered pure by default because we are mostly just assigning properties in them, right? And when you call an impure method on an object, it's going to forget the state of the object. So I was lying a little bit here. So when you call the setter and consider that the setter is going to have a void return type, this error is not going to happen because, yeah, on the first line, we remembered that getName is going to return null, but then we immediately are invalidating this state by calling a setter that returns void. So this error is not going to happen as long as setName is returning void. And sometimes this behavior is wrong, right? What if we have a getter that has some kind of side effect, or if it reaches some global state? So global state is asking the random number generator for a value. It's depending on time. It's reading something from the database, reading something from the disk. So functions that depend on global state are impure. But this function returns a value, and by default, PHPStan would consider it pure. So it should return the same thing every time. And if we run into a bug that's related to these heuristics, we need to persuade PHPStan that it's impure. So we can do this with a PHP doc. So on one-by-one basis, you can override this default behavior with this PHP doc tag. And of course, we are talking about tuning PHPStan to maximum strictness, so you can turn this behavior around if you want stricter code. You can set remember possibly impure function values to false, and this is no longer going to apply to your analysis. So if you do this, all functions that are returning a value are now considered possibly impure. So if you call something a second time and you rely on the fact that it's going to return the same thing, PHPStan is going to say, no, this can still be null even if you access it a second time after checking the value. And again, if you use this value, you switch the global behavior to behave in an opposite way. And with this option set to false, you can then opt functions in, and if you want to use something this way, like calling something multiple times so that it's the return value is remembered for future calls, you can mark function explicitly as pure with this annotation. And the good news is that if you mark something as pure and you call it without reading the returned value, PHPStan is going to tell you that you probably don't have to call it. So in case of void functions, you call them, and you are not supposed to be interested what they return because they don't return anything. And in case of pure functions, you should always read the return value because otherwise there's no point to calling these functions because they should have no side effects. Okay. This is one of the slides where even if my monitor is inverted, I made sure that this is going to be red, so I actually had to switch the original color to blue in order to be red. And it's to make my point clear that PHPStan offers these options. They are set to true by default, and you can set them to false, which means that in some situations, level 6 is not going to require you to declare missing types. So in case of generics, in case of generic classes, and in case of arrays, if you set this to false, PHPStan is no longer going to bother you that you should say what's in an array. So if you have this in your config, you should just remove these settings, and PHPStan is going to tell you that you should declare what's in your arrays and what's in your generic objects. And you will probably find more bugs if you put type hints in more places. All right, so who uses bleeding edge? One person, again. It's the same person that uses the implicit mixed. So they are really on top of things. So the point of bleeding edge is that I don't work on the next major PHPStan version in a separate branch, but instead I release the code that's supposed to be for the next major version in the current stable release, but it's turned by default. It's behind feature toggles. And if you basically want to peek into the future, if you want to see how PHPStan 2.0 is going to behave, you can enable bleeding edge, and you will basically get more features this way. It's not only new rules. It's also I call this behaviors. So some behaviors I change some behaviors that I don't like, and I'm also looking for early feedback from these early adopters that use bleeding edge. And you can also get some really minor BC breaks. So if you, for example, have some custom rules, it's possible that they are going to break. But if you fix them so that they work with bleeding edge, you can also be sure that you are going to be ready for 2.0. I could release PHPStan 2.0 basically at any time if I just enable all of these by default, but hopefully I'm going to be able to release it later this year. So if you enable bleeding edge and you fix all the new errors that you got, you can be sure that you will be ready for 2.0 now, and you are not going to have any problems upgrading. One of the things that bleeding edge enables is the list type. So list is a subset of an array, and the idea is that the array more resembles actual arrays from other languages. So PHP arrays are a lot different to, for example, JavaScript arrays, because PHP arrays are several data structures combined into one, right? And if you want like the actual arrays, meaning that the indexes of the array are integers, and they always start from 0, and there are no gaps in these indexes, which means that if you have an array with 32 elements, it's always going to be indexed from 0 to 31. So those are lists. And if you want to start using lists, you should enable bleeding edge. Another feature that I'm really excited about with bleeding edge enabled are detecting wrong inline vertex. So I really hate inline vertex. They should be eliminated from the first face of the earth, because people use it for all the wrong reasons. When you are assigning something and you don't like the type that is being assigned, you should fix the type that is on the right side of the assignment. You should make sure that the function returns the correct type already. You should not fix it afterwards with an inline var tag. If you call function function like this 1,000 times in your code base, you would have to fix it 1,000 times with an inline var tag. You should instead make sure that the type the function returns is already correct. And PHPStan offers a lot of facilities to be able to do that. So you can use conditional return types, you can use generics, you can use extensions, you can use stub files if you don't like, if you think that if you are calling some third-party library and they have wrong PHP docs in their code because they are not using static analysis, you can fix that instead with a stub file by overriding these PHP docs and register this stub file in your PHPStan configuration file. And you should basically never use inline var tag. And because people use it for a lot of different reasons, PHPStan cannot say that your @var tag is wrong because you are precisely using it to correct wrong information. So it's really hard to validate anything about it, but at least I figured out a single scenario where I can actually complain about where something wrong is in your var tag, and that's when you are assigning a method call or a function call that has a native return type. And when you have a native return type, and you say with your var tag that no, this can also be null, but in fact it cannot be null because the function uses a native return type, I can complain that php tag @var with type string null is not subtype of native type string. So this message suggests that you can still narrow the type. So you can, for example, say that it's going to be a non-empty string. That's probably, even if I don't like using it like that, it's probably a valid usage of @var if you are saying that this is narrower, but you really cannot say that it's wider, right? This can never be null, so it's wrong to say that in @var. So this is also part of bleeding edge, and if you enable it, you can expect errors like this to show up. And it might surprise you that bleeding edge, in some cases, on huge code bases, can be faster. Because in bleeding edge, I can afford to make some BC breaks for custom rules. And what I did there is that I broke some reference cycles in the AST, in the code representation that PHPStan uses. And when I broke these reference cycles, like objects pointing at each other, I realized that the garbage collector, PHP's garbage collector, has nothing to do anymore. So because it has nothing to do, PHPStan consumes less memory and takes less time. So in some circumstances, you can find that you have better performance when running PHPStan and also lower memory consumption. It might not apply to you if you have a small code base, but in some cases the difference can be really huge. So for example, when running analysis on PrestaShop in GitHub Actions, the time was cut in third. Okay, so you can experience bleeding edge. You can experience what PHPStan 2.0 is going to be about today if you enable bleeding edge. And when I actually release PHPStan 2.0, sorry for blinding you, this is the only white slide I have. These new features are going to be enabled for everyone when PHPStan 2.0 is released. And also when I release it, I'm going to sell this new elephant that I have a prototype here of. So you will be able to buy it when I release PHPStan 2.0. Okay. You can also look, besides PHPStan strict rules, you can also look at many other rules and extensions. So you can head to PHPStan's website, to documentation, user guide, extension library, and look there. I have some examples here. So if you are using some popular framework like Symfony or Doctrine or Laravel or PHP Unit, there is a big chance that there's going to be some extension. That one point of these extensions is that they make some errors go away. Basically, they make false positives go away by making PHPStan understand the code better. And also, they will introduce new errors that are specific to the framework. So basically, who uses Doctrine? And do you use PHPStan Doctrine extension? Yeah, so one of the point of this extension is that it's going to validate your DQL queries that you have in your code. So it's going to look at your entities and at your DQL queries. And if you are, for example, accessing some field that's not persisted or does not exist, PHPStan is going to tell you. And there are also some third-party rules. So Chipmunk, PHPStan rules, has one of the most extensive libraries with 40 custom rules. Chipmunk is actually one company that I know of that employs a developer that works full-time on custom PHPStan rules at their company, because they have like 40 developers. So at that point, if your team is so big, it's beneficial to have a role specific for making the developer experience of the other developers better. So they have someone who works on custom rules full-time. And you can also install packages from Markus Stab, who is a very active contributor to PHPStan. And he has an extension that, for example, if you are using Doctrine Debug or PDO or MySQLi to execute queries against the database, it's actually going to ask the database what the columns in your tables are, and it's going to narrow down, it's going to specify the types returned by the queries in your code. So suddenly you're going to know that this variable is going to contain an array of with these indexes and with these values. And the other extension from the same developer is PHPStan to do by. And the idea is that if you have a to-do comment in your code that mentions a specific date, the analysis is going to fail after this date. So you can have some kind of deadlines in your code like that. And he really worked on this recently, and he improved it a lot. So for example, now you can also reference GitHub issues and Jira issues, Jira tickets in your comments, and the analysis is going to fail when the ticket is closed. And last but not least, you can also install PHPStan disallowed calls, and you can configure it to basically say what kind of functions you never want to see in your code. So for example, if you often use debugging statements in your code like vardump or dd or something like that, and you often forget it and it gets to your production, you can install this extension, and you can configure it so that it's reported as an error during a static analysis. And you can also look for more packages, for more custom PHPStan extensions on packages if you search for PHPStan, and then click, sorry for the vertigo, sorry. It moves too quickly. So on the right side, there's a sidebar, and you can click on PHPStan extension type, and you can look for all the extensions that exist in PHPStan. If you have any questions, don't hesitate to ask me in GitHub discussions. If you have any problems or questions, myself or other contributors are eager to help you. And if you like PHPStan, feel free to use GitHub sponsors to send a few bucks my way, because I work on PHPStan full-time. It's my job. I really love doing it, but I rely on GitHub sponsors to be able to fund the development. All right, thank you very much, and please also rate my talk on Joined In. Thank you.